Medical disclaimer: the content on this channel is for educational and informational purposes only and is not intended as medical advice. Always consult a qualified healthcare professional or registered dietitian before making changes to your diet, starting a weight loss program, or if you have any health conditions. Results may vary. Peptides Explained, a beginner's guide to GLP-1 and beyond, the natural versus synthetic debate. Module 1, Peptide Basics: what are they and how do they work? To understand the massive buzz around weight loss drugs and anti-aging therapies, we have to start at the molecular level. What is a peptide? Think of peptides as the body's text messages. They are short chains of amino acids linked together by chemical bonds called peptide bonds. If amino acids are letters, a peptide is a short word or sentence, typically 2 to 50 amino acids. If that chain gets much longer, usually over 50 amino acids, and folds into a complex three-dimensional structure, it becomes a protein. Amino acid plus amino acid plus amino acid equals a peptide chain, short and amp, linear. Hundreds of amino acids plus complex 3D folding equals a protein. Because of their small size, peptides can slip into specific cellular receptors throughout the body, turning biological processes on or off with incredible precision. The lock and key mechanism: peptides work via a receptor-ligand mechanism. Think of a cell as a locked house. The cell surface is covered in locks called receptors. A peptide acts as a specific key, a ligand. When the correct peptide bumps into its matching receptor, it unlocks the door and triggers a cascade of chemical reactions inside the cell. For example, growth hormone secretagogues, GHSs, bind to receptors in the pituitary gland, telling it to release natural growth hormone. GLP-1 receptor agonists bind to receptors in the pancreas and brain, telling the body to release insulin and signal fullness. Module 2, the GLP-1 revolution. The undeniable superstars of the modern peptide world are GLP-1 receptor agonists. Originally developed to treat type 2 diabetes, they have completely shifted how medicine approaches obesity. What is natural GLP-1? GLP-1, glucagon-like peptide 1, is a hormone naturally produced by your L cells in the gut in response to eating food. It is part of the incretin system, a group of metabolic hormones that stimulate a decrease in blood glucose levels. Natural GLP-1 has a major flaw: it has a half-life of only 1 to 2 minutes. An enzyme in your body called DPP-4 hunts down natural GLP-1 and breaks it down almost instantly. This means natural GLP-1 cannot be used as a drug; it disappears too fast to have a sustained effect. Enter the synthetic agonists. To solve this, scientists created synthetic versions that mimic natural GLP-1 but are chemically tweaked to resist DPP-4 breakdown. This brings us to the medications dominating the landscape today. The following slide illustrates some examples. The triple action power of GLP-1. How do these peptides actually cause dramatic weight loss and glycemic control? They pull 3 distinct levers in the body. The pancreas, they trigger insulin release only when blood sugar is high, while suppressing glucagon, a hormone that dumps sugar into your blood. The stomach, they slow down gastric emptying. Food literally stays in your stomach longer, physically keeping you full for hours after a meal. The brain, they cross the blood-brain barrier and bind to receptors in the hypothalamus, shutting off the constant biological urge to eat, often referred to as eliminating food noise. Module 3, Beyond Weight Loss, the exploding peptide landscape. While GLP-1 dominates headlines, the broader field of peptide therapeutics targets everything from tissue repair to cognitive enhancement. 1. Tissue repair and healing peptides. BPC 157, Body Protection Compound 157, a synthetic peptide derived from a protective protein found naturally in human gastric juice. In animal and in vitro studies, it has shown a remarkable ability to accelerate the healing of tendons, muscles, and ligaments by promoting angiogenesis, the formation of new blood vessels. TB500, thymosin beta-4 fraction, a synthetic version of a naturally occurring peptide present in high concentrations in blood platelets. It plays a vital role in cell migration, tissue repair, and reducing systemic inflammation. 2. Growth hormone optimizers apomorelin and AMP, CJC 1295. These are often paired together. They are growth hormone secretagogues. Instead of injecting synthetic human growth hormone HGH, which can shut down your body's natural production, these peptides signal your pituitary gland to release its own stored growth hormone in natural, healthy pulses. 3. Cellular health and longevity. Epitalin, epithalon, a synthetic peptide based on a natural substance produced by the pineal gland. It is heavily researched for its ability to activate telomerase, an enzyme that helps maintain and repair the protective caps on the ends of our DNA strands telomeres. MoC, a mitochondrial-derived peptide that regulates metabolic homeostasis. It acts as an exercise mimetic, tricking the body into improving insulin sensitivity and physical performance at a cellular level. Module 4, the natural versus synthetic debate. There is a lot of misinformation surrounding natural versus synthetic peptides. Let's look past the marketing language and clear up how these compounds are actually classified and perceived. The chemical reality. Biochemically speaking, your cells cannot tell the difference between a natural peptide and a highly purified synthetic peptide. If the sequence of amino acids is identical, the biological response will be identical. A synthetic peptide is simply built in a laboratory using a machine called a solid-phase peptide synthesizer, rather than being harvested from an animal or plant tissue. The 3 categories of peptides. To understand the debate properly, we have to look at how a peptide is designed. 1. Bioidentical, exact copy of what your body makes, for example, natural insulin. 2. Biomimetic, tweaked structure to improve duration or power, for example, semaglutide. 3. Novel synthetic, completely engineered in a lab, does not exist in nature. Pro-natural arguments. Those who favor natural approaches, or lifestyle interventions that raise natural peptide levels, point to several factors, the inherent feedback loops. When your body makes natural GLP-1, it releases it in precise amounts alongside dozens of other codependent hormones. It is automatically regulated by natural feedback loops. Zero synthesis contaminants. Natural peptides made by your body are inherently pure. Laboratory synthesized peptides must go through rigorous purification processes to remove residual chemicals used during manufacturing. Pro-synthetic arguments. The clinical reality is that synthetic modifications are what make peptides viable as modern medicine. Enhanced bioavailability and half-life. As mentioned with GLP-1, natural peptides degrade in minutes. Synthetic modifications, like adding a lipid chain to semaglutide, allow these therapies to work for a full week, making treatment practical. Potency and target specificity. Synthetic engineering allows scientists to make a peptide link stronger to a receptor, or even link to multiple receptors simultaneously, like tirzepatide hitting both GLP-1 and GIP, achieving therapeutic results that lifestyle modifications alone cannot match. Module 5, Safety, Legality, and the Gray Market. The massive demand for peptides has outpaced the traditional medical supply chain, creating a massive, unregulated gray market. Understanding the difference between clinical-grade medicine and research chemicals is critical. The danger of research chemicals. If you search for peptides online, you will find hundreds of websites selling them under the disclaimer, for research laboratories only. Not for human consumption. These are unapproved, unregulated products often sold in vial form as a freeze-dried, lyophilized powder. Buying from these sources carries significant risk, purity and sterility. Issues. Industrial or gray market synthesis can leave behind heavy metals, residual solvents, like trifluoroacetic acid, or harmful bacterial endotoxins. Dosage inaccuracy. Independent testing of gray market peptides frequently reveals vials that are severely underdosed or completely mislabeled. Lack of counter-regulatory safety. When using a powerful metabolic or endocrine modifier without a doctor's supervision, you risk severe side effects, including pancreatic stress, thyroid complications, and severe dehydration from gastrointestinal distress. How to safely navigate peptide therapy. If you are interested in exploring peptides, the safest path avoids the internet gray market entirely. Consult a licensed physician, seek out an endocrinologist, metabolic specialist, or a physician well versed in peptide therapeutics. Use FDA-approved medications. Whenever possible, use standard, FDA-regulated medications manufactured by licensed pharmaceutical companies and dispensed through legitimate, brick-and-mortar pharmacies. Utilize accredited compounding pharmacies. If an FDA-approved drug is unavailable or cost-prohibitive, a licensed physician can prescribe customized formulations through accredited, state-regulated compounding pharmacies that maintain strict quality control standards. Summary focus: the big takeaway. Peptides are not magic, they are simply tools of cellular communication. While the synthetic engineering of molecules like GLP-1 has given us unprecedented control over metabolic health, obesity, and tissue repair, these compounds function best as a supportive bridge alongside foundational lifestyle choices, including a nutrient-dense diet, resistance training, and proper sleep hygiene. Where would you like to dive deeper? Compare semaglutide versus tirzepatide side by side? Explain BPC 157 and healing peptides in depth? How to naturally boost GLP-1 through diet. Any trade or registered names used in this video are the sole property of their respective owners. Leave your comment. We read them all. Like this video. Share this video with your friends.